So looking at our negation rules for each of our quantifier, for the first one here, these are probably going to be the easiest ones, these first two. And so the negation of if, or excuse me, for all is going to be logically equivalent to there exists some variable x such that not p. So similar to when we were doing our nots, our negations for our propositions, it's going to work very similar. So remember that this is a capital P, so I'll try to make that more distinct. This is a predicate, not a proposition, but it works very similar in terms of negating. So really the negation part here is the opposite of for all is there exists, and then we need the not P portion. Similarly for the negation of there exists, that's logically equivalent to for all x, not p. So these two kind of go hand in hand together. The last one's a little weird, I do have to admit. So bear with me and we will do an example for this one so that you get a good grasp on what exactly this is talking about. So for the exactly one negation, this is going to be logically equivalent to an or statement. So this is going to be either for all x, not p, or there exists and this is the notation we're going to use here. There exists x1 is not equal to x2. So basically the statement here is at least two students, essentially. So not one, but two. So that's kind of the opposite here. And we'll look at an example so that you get a good grasp on what exactly this is talking about. So let's look at an example here. So the way that this is going to work for your classwork, there is going to be a sentence written. So let's just go ahead and write that out. So every major has at least one student declare it. So the first thing that we want to do is write this in logical form. And this is going to be for all x, there exists a y such that p. So that's the form here. So if x is the variable major, y is students, and then p is the form x major declares y students, or y students declare x major, or something like that, like to fit the form that we did before. So then we want to negate this statement. So the negation of this would be, so let's just rewrite what we have here. So this is going to be logically equivalent to there exists x for all y, not p. And then we want to rewrite this in plain English. So there exists at least one major in which all students do not declare it. So again, make sure that we are saying not P. So that is one thing that a lot of students that I've seen leave out, is that when we negate the whole statement, we need to make sure we're negating the P. So students are not declaring. So the opposite of every major has at least one student declare it is there exists at least one student in which all, there exists at least one major in which all students do not declare it. So let's do another example here, where we take a look at the negation of exactly one. So our first statement is at least one major has exactly one student declare it. So our logical form, we're going to put this in first. So at least one major, so there exists X, exactly one Y, P. So that's our logical form. So when we are going to negate this, let's again just rewrite our statement here, just so that we know what we're negating. And I'm going to need a lot more space, so we're going to do this on the next line. So it kind of works like a distributive property. So I'm essentially distributing the negative to each of these inside terms. So if I negate the there exists X, we get for all X, and then comma, and then I'm essentially distributing to this there exists here. And we know that there are two terms essentially that we're going to produce, because if we go back to our notes, this is our negation of a there exists. So we're going to have two sort of situations here. So just like we did with our logical connectives, I'm going to put this in parentheses just so that we know that this for all X is going to apply to both of these terms that we have over here. So for all X, either for all Y not P, or there exists at least two P. So then putting this back into a plain English, we get, so the first term here, so every major, or for all majors, or whatever you want to write it as, they both mean the same thing. Every major either, because we have this or here, so either has every student not declare it, or, so again, that or there, has at least two students declare it. So again, this one seems a little bit counterintuitive, but we sort of have this conditional thing going on here, because we're trying to negate this there exists exactly one. It's a unique quantifier. So either the opposite of that is no one declares it, or at least two. So we kind of have this sort of spectrum of things going on here. So if I draw this out on a curve of sorts, let's just do a number line here. So 0, 1, 2, and then so on. Well, we can't really have negative students declaring things, so we're kind of going to have this ray going on. So if we're here and we're trying to sort of negate this, we can go in either direction. Either nobody declares it, and that's where we get this first condition here, saying that nobody is declaring the major, or we kind of get this spectrum here, well, then maybe at least 2 students are declaring it. So that's sort of why we have these 2 statements going on, the or here. Let me erase this. Let me erase this line so that you don't think that that's a exclusive or. So let me be careful with my notation. That was just emphasizing the or here. So that's why we kind of get these 2 statements going on here. So either nobody declares it, or at least 2 people declare it. So that's the opposite of our one person declaring it. And then from here, we're going to go ahead and do our classwork for these examples. So if you have any questions on this lecture, please just tune in to my Zoom call. I will be available starting at 1 o'clock. All right, have a great day, everyone.